Welcome to episode 13 in the Inside xtUML Learning Series, and thank you for joining me. My name is Dean MacArthur, and in this segment we will be looking at how xtUML model data can be shared between modelers, and versions of a model shared across a team. Along the way, I will demonstrate each approach and provide suggestions to ensure modeling activities can progress concurrently. The Inside xtUML series is sponsored by the xtUML.org community, and I encourage you to visit their site to learn more about the organization. This episode is part of an ongoing series of presentations covering all aspects of xtUML modeling. If you have missed an earlier segment, it can be viewed using the links at the xtUML.org site or at YouTube on the xtUML channel. Earlier in episode 12, xtUML project structures for individuals and modeling teams were presented. At the conclusion of that presentation, a question was raised regarding how to incrementally advance models without impacting the activities of other team members. The answer lies in the tools and techniques of version control and configuration management. To explore this topic, I will follow an agenda that begins with a discussion of simple version management. This approach is typically used by individual modelers to store and share versions of their work. However, when more modelers are involved, the number of versions needed to efficiently progress the overall model quickly explodes, and more elaborate tools are required. The Eclipse environment includes version control and configuration management tools that are fully integrated with the xtUML editor. These tools and techniques will be explored in the second half of today's presentation. This exploration will be accompanied by demonstrations, and I encourage you to follow along on your own desktop using the xtUML editor and the GPS watch example. Simple version management involves the storage and sharing of individual projects or an entire workspace. The approach utilizes the Eclipse project import and export functionality to create archive files of the project. These archive files are snapshots of the project and can be used as backups should the workspace become lost or corrupted, or as a version from which the model can branch in a new direction. Each archive contains only the contents of the project, and typically within these contents there isn't a unique version identifier. Consequently, it is important to uniquely name each archive such that the project and version ID are prominent. Once the archive file is created, it is then transferred to a safe storage location outside the workspace. This folder is often called a repository, and each modeler will have a unique repository location to hold their archive files. To share a project archive requires that the file be manually copied from the source repository into the working area of the destination user. It is helpful to organize these received archive files as part of the destination user's repository. This will reduce the chances for the archive to be lost or corrupted. Once stored in the destination work area, the Eclipse import facility can then be used to include the project in the current workspace. Since the project files in the workspace are copies of the original work, they can be modified locally as needed without impacting the progress of the original project. If the changes are to be reflected back into the original model, then a new archive file must be created using the export process. The original modeler must then import the file into their workspace and integrate the changes. This process of creating and exchanging archive files will be repeated several times during the development of a model. To see this process in action, start the xtUML editor. In an empty workspace, add the GPS watch example. This is the same model that has been used throughout the Inside xtUML Learning series. It contains 4 components: a user interface component, a tracking component to process and organize the sensor data, a heart rate monitor component to capture data from the heart sensor, and a location component that continually tracks the current position of the watch using signals from the GPS satellites. To create the archive file, select the project, pull down the File menu, and then click on Export. Under the General folder, select Archive. This will bring up a second window where the files to be archived are listed. I suggest always including the entire project folder in an archive. Archive name is entered, and then the destination folder is selected. Once these entries are completed, click on Finish, and the export functionality within Eclipse will then process the request and produce the archive file. Next, I'll switch to a new workspace. Here I will switch from the Workspace Project Export into a new workspace called Project Import. Into this workspace, I will import the archive file that was just generated. Although the original archive was captured using the archive file functionality, when importing, use the existing projects into Workspace. This option includes extra functionality that will check the archive for consistency and ensure that a proper project is imported into the workspace. Will require that you select the file. It will then provide a list of projects that are contained within the archive. From that, checkmark those which are desired, then press Finish. The workspace will be updated to include, in this case, the GPS watch project. All the data, the links, and the model elements have been successfully transferred to this new workspace. For small teams, the archive approach can create a number of challenges. As the complexity of the model and the size of the project team grows, the number of versions being produced also grows. This problem is even greater if the team chooses the distributed project structure to organize their model. Coordinating the use of these archive files such that each team member has a repository and workspace with an up-to-date model that is also consistent is a nightmarish challenge. The solution for many small teams is to use the tools and techniques of configuration management. These tools use a single repository to store all versions and permit multiple users to commit and retrieve versions from the repository. There are many tool options, and each offer a unique interface. Fortunately, Eclipse provides the team interface to standardize the access of Eclipse projects to these various repositories. Even though the underlying configuration management tools may be different, their appearance and usage by Eclipse users is the same. So the steps shown during today's demonstration will be the same whether you use CVS, Subversion, or Git for managing the repository. The process that these small teams typically follow is an extension of the simple archive approach discussed earlier. At the start of the project, a consistent model is committed to the repository, and each modeler then retrieves this same model from the repository so that the team has a consistent starting point. Each modeler then works independently in their Eclipse workspace to advance their portion of the model. As needed, they will commit versions of their work to the repository and the configuration management software tracks the changes and records the differences. If the workspace is lost or the modeler desires to return to an earlier development point, then the appropriate workspace versions can be tracked down using the details retained by the tool and the correct projects retrieved from the repository. Portions of the model will develop at different rates. In the distributed model, the development efforts in each workspace are dependent on the progress of the other model elements. So at strategic moments, each modeler will update their Eclipse workspace with versions of the work committed by other team members. These strategic moments can be associated with a model's functional maturity, its stability during testing, or simply at prescribed time intervals. It is through these project-wide synchronization activities that the overall model is able to incrementally progress, even though each team member is advancing at their own rate. To better understand the configuration management process, as well as the activities of commit and synchronization, let's return to the xtUML editor and a workspace containing the distributed model of the GPS watch. The first step is to populate the repository with the reference model that each project member will start from. The repository is selected using the appropriate repository browser. To activate the browser, select the folder associated with your configuration management software. In this demonstration, I will be using a repository that was constructed using Subversion, but the steps are equally applicable to CVS and Git repositories. To add the projects to the repository, select the projects in the Menu Explorer window, and then with the right mouse button, bring up the Team menu. This menu will include the item Share Projects. Select this item and the Add Projects wizard will appear. Next, confirm the destination repository address. It is convention that reference models and primary development work be located under the head folder, while experimental or potentially conflicting work is placed in a folder underneath branch. In this case, I will be placing my models under head in the folder Improved GPS Watch. To improve traceability of the various versions, a meaningful comment is added to each commit of projects to the repository. The projects and then the files associated with each project are then added to the repository. The reference model is now committed to the repository and can be retrieved by each of the team members. To retrieve the reference model, I will switch to a new workspace. In this case, I am using an empty workspace, but that's not required. In most cases, these models will be added to a workspace that includes additional projects that support the activities of that modeler. Having added the repository browser, I can now select the reference models that I require. Using the team interface, I click on Checkout to bring these models from the repository into my current workspace. Once in my workspace, I am able to enhance this model according to assigned requirements without impacting other team members. While enhancing this model, my work will follow the stages of the xtUML process, and eventually I'll be ready to commit a version back to the repository. For this example, I will extend the units enumeration inside the UI data types. Before sending a version of this project to the repository, I will check to make sure my changes will be applied to the latest version. This check is performed by the team function synchronize with repository. After completing this check, a list containing only my changes should appear. I can check that the identified difference is indeed my intended change by double-clicking on the UI Data Types package. This will open a comparison window that shows, on the left side, the differences found in my workspace version, and on the right side, those found in the latest version from the repository. Navigating through these differences will allow me to confirm that all the changes will be correctly applied. Now it is safe to commit the changes, and the first step is to select the root folder of the project. Next, use the right mouse button, select the Team Commit function to start the commit wizard. After entering a meaningful description of the changes into the comment box, the changes will be transferred to the repository and tracked as part of the project's history. Within the history, the files and the comments associated with each revision are tracked. For other modelers on the team, if this change led to a strategic version, then an update to their workspace is required. The first step in performing this update is to select the Synchronize with Repository item from within the Team menu. This selection will provide a list of all differences, and each can be inspected by double-clicking on the item, which will open the comparison window. Since the project work is being performed by a small team, it is likely that the changes will not interfere with uncommitted changes in the local workspace. Consequently, select Update and the revision changes will be brought into the local workspace. After the entire team has completed these updates, then the project is said to have synchronized. Navigating through the project, we see that the changes made earlier and then committed to the repository are now part of the local workspace. Using configuration management helps to organize and track the many versions of a project that a team can produce. However, for larger teams, it is more likely that some projects within the distributed model will be modified by multiple modelers. If each modeler tries to use only the head version, then their changes will likely conflict with the changes introduced by other modelers using the same project. To address this problem, large teams will create duplicates of the common project and store these replicas in a separate area of the repository. Each modeler then builds their workspace based on these branched versions of the project, and then performs their modeling activities. Once the work has progressed to a stable state, the changes contained in the branch are then merged back into the head version. Configuration management tools provide comparison reports and merge editors to help form the new reference. The Compare window appears when a difference identified using Synchronize with Repository is selected. This window opens with a side-by-side list of differences that can be expanded. The Merge editor will open once a difference is selected. The Merge editor is a side-by-side editor that displays the differences in highlighted boxes. In this view, it is possible to accept, reject, or manually enter the appropriate merged result. Once decided, the master version in head is updated to match the merged project. Before starting to create a branch project, it's important to prepare the repository. This involves creating a destination folder under the branch hierarchy. Once the destination is available, then select the projects to be branched, and using the team interface, create a new branch. Note that the version numbers of the branch folder are different from those in the main version under head. Now create a new workspace to contain the work associated with the tasks needed to modify the branched project. Once created, check out the projects associated with the branched activity. Perform the needed revisions to the model. In this case, I will modify the state machine contained within the heart rate monitor component. These changes will include both the addition of action language and the modification of the state machine diagram. The changes will now be committed to the repository. The first step is to perform a Synchronize with Repository function to verify that only the intended changes are to be updated. As mentioned before, the commit should always be made from the root folder containing the change, and not from lower in the hierarchy. Once a comment is provided, the commit will be completed. Note that the revision number will advance as shown by the Repository Explorer. This new revision number matches the branch folder and not the master project under head. This can also be confirmed by looking at the history for the two projects. The final step in this demonstration is to perform the merge of the branch changes back into the main project under head. This work will be performed in a new workspace. This workspace is populated using projects checked out from the repository under the head folder. Next, the Merge function under the Team selection is used to synchronize the changes found in the branched project back into the local revision. The results will open the comparison window and differences can be inspected. Both action language and graphical differences are found. Once the changes are ready to be accepted, click on the Accept Incoming Messages icon and the branch changes will be merged into the project. To finalize the changes, commit the local project to the repository. As we have seen, sharing projects efficiently between team members can be challenging. For a small project or simple changes to a mature model, the use of archive files can be appropriate. These files are exchanged between model workspaces using the export and then import project facilities of Eclipse. Large teams or more complex models find archive files to be inefficient and hard to track. Instead, these modeling teams use configuration management tools, and as today's demonstration showed, the xtUML editor has a unique graphical approach to supporting these tools. This concludes the Inside xtUML episode on configuration management. Thank you for joining me.